Okay, ladies and gentlemen, let's start with a polygon family tree. Now, obviously our most basic building block is point A. If we string a bunch of points together, we get a line segment. That's segment AB. If we string a bunch of points together in one direction infinitely, that's a ray AB. If we string a bunch of points together infinitely in both directions, now we're talking about line AB. But by combining line after line after line, we create a plane. And that plane in this case would be plane ABCD. Now, these are the basic building blocks of all that we're going to do. Those one component pieces, when added together, like the following, you get two parts. So by adding two rays together at a vertex, they form sides. Those sides with a vertex form an angle. That angle, in this case, is ABC or CBA. That angle can be acute if it's less than 90 degrees, right if it equals 90 degrees, 120 degrees would give us obtuse, and finally, a straight angle would be 180 degrees. That's using two parts rather than one part. But if we add a third component in, let's take three segments and put them together. Now we have a triangle ABC, BCA, CBA. And it comes in a variety of options as well. If all the angles are acute, it's an acute triangle. If a single angle is right, it's a right triangle. If one angle is obtuse, it's an obtuse triangle. But that's dealing with angles. If instead we look at sides, no sides the same length would make it scalene. Whereas if two sides are the same length, it's isosceles. If I have three sides the same length, it's equilateral. Now that's six, but there's technically a hidden seventh because going down the angles and the sides, we find that, well, wait a minute, if all the angles are equal, that would make equiangular, which is the same as equilateral. Now, let's add four components together. So if I put four pieces together, making sure that they're connected and obeying the rules of polygons, I have at best a quadrilateral because there are no congruent sides and no congruent angles. If I make one set of sides parallel, that's it. That's all I know. It becomes a trapezoid. But if instead I have one set of sides that are parallel and one set that are congruent, now it's isosceles trapezoid because two sides are the same. If two sets of sides are parallel rather than one set, it's a parallelogram. Let's take that parallelogram and stand it up straight and give it some right angles such that opposite sides are parallel, opposite sides are congruent, and all four angles are right. It's a rectangle. If instead of standing it up straight, we just squish it and make all the sides congruent, it's a rhombus. But in either case, whether I stand up a rhombus, I've already made four sides equal, or I squish a rectangle to make those sides equal, they lead to a square. But the black sheep of the family is a kite. A kite has two sets of congruent sides that are adjacent. And it would tie back into rhombus. When we start moving to five or more pieces, now we only have two options rather than all these different pieces. It's either non-regular, or it's going to be regular. Non-regular figures don't have all congruent sides and angles, whereas a regular figure has all congruent angles and congruent sides. But in non-regular, at least one has to be different. Not all of them have to be different. But let's keep going. For a five-sided figure, it's going to be a pentagon. For a six-sided figure, it's going to be a hexagon. For a seven-sided figure, a heptagon. 8 would be octagon. 9 would be nonagon, 10 would be decagon, 11 would be undecagon or undecagon, and 12 would be dodecagon. Beyond that, you just call it 13 gon or 14 gon.